Good morning, all. So, this is our subject Advanced Machine Learning meant for MTech students. Today's topic being discussed is K nearest neighbors. And the textbook we are referring for the topic is Mastering Machine Learning. This Jason Browley's book. So KNN, this is the short form. KNN stands for K nearest neighbors. KNN stands for K nearest neighbors. It's a classification and regression algorithm. It is also called as a lazy learner algorithm as it doesn't learn anything from training data. It is a supervised learning algorithm. It uses Euclidean distance as a similarity measure, and it is a non-parametric learning algorithm. So how do I represent the KNN model? Okay. For representing the KNN model, I have to take the entire data set, training data set. So why learning is not there? Because there is no model for storing the entire data set. So predictions with K nearest neighbor. So for prediction, KNN uses the entire training data set directly. Predictions are made for a new data point by searching the training set for K most similar instances, the neighbors, and summarizing the output variable for those K instances. If it is regression, it will be mean output. If it is classification, it will be the most common value or the mode. So similarity is identified with the help of distance measures. The most famous distance measure is Euclidean distance. Now, how do I calculate Euclidean distance? Find out the square root of the sum of the square differences between a point A and point B across all attributes of I. This is usually the formula, square root of Q1 minus P1 whole square plus Q2 minus P2 whole square, like your Pythagorean formula. Along with Euclidean distance, what are the other popular measures for distance? You have Hamming distance, you have Manhattan distance, you have absolute distance, you have Minkowski's distance, and many more. Now, I need to assume the value of K. Now, how do I assume the value of K correctly? By tuning the algorithm. So, you can take the values of K right from 1 till 21 and see which one works best for you. As the training data size increases, the complexity increases. If the training data sets are huge, KNN can be made stochastic, as in you take some sample from that. If we are using KNN for regression, the prediction is based on the mean or median of the K most similar instances. If we are using KNN for classification, the output is calculated as the class with the highest frequency from the K's most similar instances. What happens is every instance votes on their class and the class with the most vote is taken as the prediction. We can also calculate the class probability by normalizing the frequency of samples. There is one word called as curse of dimensionality. So curse of dimensionality, what it indicates is K nearest neighbor works well if the number of input variables are less. But if the number of input variables are increasing, the KNN will falter. Each input variable you'll be considering as a dimension. So suppose you have two input variables, so it's a two-dimensional space. As the input variable increases, the dimension increases. When high dimensions occur, the points that may be similar may have very large distances. The points will be far away from each other. And the intuitive way of resolving the distance breaks down. So, and this will not lead to unintuitive. This will not lead to unintuitive. This is called as curse of dimensionality. This is called as curse of dimensionality. Let us look at the algorithm now. Let us look at the algorithm. K nearest neighbor algorithm. The steps for K nearest neighbor algorithm are as follows. Load the training data as well as the test data. Choose the value of K. For every point, calculate the Euclidean distance. After that, sort them in the ascending order. Choose the top K rows from the sorted array. Assign a class to the test point based on the most frequent class of this row. Very easy. But let us see how it happens. I have an Excel data here. I have an Excel data here. See here. Let us say I need to predict the class of this last row. By the way, this Excel sheet consists of what data? This Excel sheet is consisting of data of heights and weights of people. Suppose first person's height is 185 and weight is 172. Second person's height is 170 and weight is 56, like this. Okay. So these are the heights and weights, and we also have the predefined classes, 3 classes. Why we have predefined 3 classes? Because the value of K we have taken as 3. The value of K we have taken as 3, and there are 3 classes A, B, C, like that. Okay. So this is the predefined data. Heights, weights, and this class is given. Now what we have to do? For which data we have to predict the class? For this data in the 13th row. This 13th row, data in the 13th row. What it consists of? The height is 171 and the weight is 73. The height is 171 and the weight is 73. For this I need to predict its class. How do I do it? Simple way is, first I'll be using the distance measure called as Euclidean distance. I'll be finding out the Euclidean distance of this row with all the rows. Say for example, this is the Euclidean distance with the first row. You can see the formula, square root of G18. G18 is this, 171. Square root of 171 minus 185 whole square plus square root of 73 minus 72 whole square. So like that, you are going to find Euclidean distance for each of the row. For each of the row with this 13th row. Once I have got this, what I'll be doing is, I'll be ordering them. What I got is, I got the Euclidean distances, similarity measures. So these Euclidean distances I am ordering. Numerical order I have done, and I can find out here. This is the ordered data. This is the ordered Euclidean distance. So the smallest one is 6.70 and the biggest one is 17.49. Biggest one is 17.49. If you look at the top 3, because the value of K is 3, I have to take the top 3. What are the top 3? 6.70, 9.21 and 9.43. So 12th instance, 7th instance and 4th instance. So 4th instance is this, 9.43. The class is C. Okay, popped up. Similarly, the 7th instance is this with the Euclidean distance 9.21 and the class is B. The class is B. So popped up. Now the 12th instance is Euclidean distance 6.70. The class is B. So what is the value of K? 3. Now we have here 3 classes popped up, C, B, B. So which is more frequent? B. As B is more frequent, the predicted class of this row consisting of height 171 and weight 73 will be treated as B. So as simple as that. There are a few codes here of R as well as Veka. You can see I'll take a walkthrough of this also. I take an IRIS data set. Then I just explored IRIS data set, its first 6 rows and the entire IRIS data set. Then I have set seed and run if I have issued. Then I applied the k nearest neighbor. So kind of, so this is kind of self-explanatory code which I'll be sharing with you. Okay, so this is it about k nearest